Hi everyone, this video is to help you guys reinforce what we learned about entity relationship diagramming in class. So I'm going to go through one or two examples on how to create an ERD, and then we'll show you some examples of what the data looks like as well. So for starters, I have Microsoft Visio here. This program is available for free through the DreamSpark website. You don't have to use this, just to be clear, but I have no other way of showing you ER diagramming. I can't draw through the computer very well, so I'm just going to use Visio, which is the most common tool actually for entry-level or beginning ERDs. So once you've installed Visio, if you want to follow along, you can just watch me and pause and learn. But if you want to follow along after you've installed it, open Visio up, and I'm going to create a basic diagram. Notice there's a whole bunch of templates here with different shapes you can use for different types of diagrams you may need to create. Lots of different options. If you go into IS or even project management, if you go into management, you'll learn what a lot of these diagrams are. So I'm going to start with a basic diagram. Create. Now notice I'm not actually creating the file, it's just saying is this the type of diagram you want to create. So this is being created in memory, not directly on the hard drive like Access is. Okay, so over here it gives me a bunch of basic shapes to use. They actually have shapes specifically meant for ER diagrams, and that'll make life a bit easier for us. So let's open some of those up. I'm going to go to More Shapes, Software and Database, I've got a few different options. The one we learned in class is closest to this crow's foot database notation. So I'm going to use that, and notice now it gives me this set of crow's foot database notations over here. So let's start with the first example, creating a transaction processing system. So let's do the more difficult example where we have non-serializable products, meaning we need to create a database to sell items or products that we don't store serial numbers for, which means that the same product can be purchased by the same conceptual product, like screws or nails, can be purchased by many different customers, and many different customers can purchase screws and nails. So let's start with our customers entity. Click and drag that on here. I think I need to zoom in to make this easier to see on the video. Let's zoom way in. Alright, so notice this is our entity image right here, and we can give it a name right here. I double click customer. PK obviously stands for primary key, and we can name what we want that primary key to be right here. Let's just call it cust ID, and then we'll obviously record other stuff about customer like their name, email address, something like that. Okay, let's try and save ourselves some space and make this a bit smaller if possible. No, it doesn't look like I can do that. Oh well, that's alright. So let's pull another entity out. This one's going to be our orders entity, or order. Primary key should be order ID. Obvious attributes we want to keep track of are the order date. Let's see, and we'll say payment type. Okay, so we've got our first two entities. We're going to have several more, but let's start by creating the relationship between these two entities. So we have the relationship image right here, or the shape, and notice it's got crow's feet and a circle and a couple of tick marks over here. Now in class I told you that you only need to learn the crow's feet to represent the many side of a relationship. I can't remove the other marks from this, so we're just going to have to go ahead and use them for this example. In case you're interested, you don't have to learn this part. Remember, the marks on the inside represent the minimum cardinalities, and the marks on the outside represent the maximum cardinalities. So this isn't connected to anything, but what these symbols mean is that an entity on this end can be stored even if it's not related to any entity on this end. That's the purpose of that 0 right there. However, it could be connected to many entities on this end, hence the crow's feet. These tick marks mean that the entity on this end of the relationship has to be related to at least one, hence that first tick mark, the minimum cardinality. Entities over here have to be related to at least one entity on this end, but at most one entity on this end as well. So, if you look at customer and order, think through it. Which end should the crow's feet go on? Where am I going to drag this? Okay, a customer can place many orders, therefore the crow's feet are going to go over here, and an order can be placed by one customer. And it's actually good we have two tick marks there because we don't even want to record an order unless there's a customer attached to it. Therefore, the minimum cardinality is 1. However, it's possible we might buy a list of customers from somewhere, from someone that we want to market to, and store them in our database, even though they've never placed an order with us yet. As a result, we would like the minimum cardinality on this side to be 0. In other words, we want to be able to store a customer without them having any orders placed. Okay, so let's stop right here, open up Excel, and give you an example of what the data would look like with these two tables. I'm going to open up a new Excel window, expand, and in case you're wondering how I did that, I just clicked and dragged the top of this window to the top of the screen and it automatically expands it out. So I'm going to start with a blank Excel workbook. Let's create a table. Actually, let's zoom in to make this easier to see. Okay, we've got our customer table right here. Maybe back a little bit. Our order table right here. And let's add the columns that should go in each table. We made a cust ID, made a name, we made an email field. For order, we have a order ID, a date, the payment. I think I made it like this. Let me see here. Now, technically I shouldn't have spaces here, so I'm going to eliminate that space. Okay, payment type. So I'm going to merge and center these two entity names, and I'm going to format both of these just so you can see very clearly where the tables are. Alright, all borders, and let's shade them in a bit. Okay, so over here we have customer 1, 2, 3, 4. Marge, Homer, Bart, Lisa, whoops. Okay, I'm just going to call these email 1 through email 4. Okay, just for the purposes of the demo. Over here, we've got order ID 1, 2, 3, 4. Let's give it a few dates. 1/1/2013. Put those dates increment. Payment type, cash, Visa, check, cash. Okay, so we have two tables. We have all the customers over here and all the orders over here. Orders 1, 2, and 3 were all placed by Homer. Order 4 was placed by Lisa. So we can't put both of these tables together because otherwise I would be listing Homer and his email address 3 times, one for each order. I think you probably get that part so far. What I need to do though is take the primary key, which is cust ID in this table and order ID in this table. I need to take the primary key from one of these two tables and copy those values into the other table so that I can know which rows are related to which rows, records. So let's do it the wrong way first, like we did last time. Remember, if I wanted to take order ID from this side and place it over here, type in order 1 and we'll call this order ID, and it becomes a foreign key on this side. I'd have to, order 1 was placed by Homer. Okay, Homer also placed orders 2 and 3. Where do I put numbers 2 and 3? Well, I can't add them over here into columns because I can't add columns automatically during runtime. If I want to add them as rows, put order 2 down here, well then I'd be repeating Homer again. Okay, and that defeats the purpose as well. We don't want to be repeating the same data. Therefore, clearly it won't work to put order ID over in the customer table. So remember the rule I gave you guys in class was that when you have a one-to-many relationship, the primary key from the one side is always going to be a foreign key in the many side. So look back at our image here. Customer to order. The relationship is one customer can place many orders. Each order can be placed by one and only one customer. Therefore, I'm going to take the primary key from the one side, which is the side with the 1 on it, and put customer ID as a foreign key over here in this side with the many on it. So let's take customer ID and add it to the order table. Cust ID. Let's format this like the other ones. Merge and center. And now we have orders 1, 2, and 3 were each placed by Homer. And now we don't have to put his name in there, we can just put his customer ID in there, and now we know that he placed each of those 3 orders. Lisa placed the last one. So we've got a relationship created now in the data between customer and order. That's what these tick marks and these crow's feet mean in this image. Alright, so hopefully you're good with this one. One-to-many relationships are the most common. Now it's time for us to include the details of each order. So if you look back here on this page, okay, order 1 may have included 4 different products on it. Okay, well, we need some way to record each product and the amount or the quantity of each product sold. Alright, I can't just put quantity right here and product ID here because each line represents one entire order. And if you can buy more than one product on an order, I would have to create multiple rows in this table to represent each of those products. And then that would repeat the date and the payment type, and that's not good. So clearly we can't put products in the orders table. Let's though first create our products table that will record each of those. So I'm going to come down here, actually click and drag and move this over now that it's created. And let's bring another entity out here. Let's move and drag this over. Call it there we go. Product or item, whatever you guys would like. We'll call this product ID. We're going to record the name of a product and its price. Clearly with each of these there would be many more attributes you'd want to record, but we're just going to keep this simple. So let's click and drag the relationship out here again. Okay, orders to products. Now what I told you guys, or we just showed you, was that an order can have many products. However, can the same product appear on one or many orders? Well, this is where that issue of serializability matters once again. If a product is serializable, meaning like cars, guns, furniture, or large pieces of furniture, each item has its own serial number attached. And that serial number would become another attribute in the products table. Well, in that case, a particular gun or a particular car can only appear on one order, right? In that case, this would be accurate. An order could have many products, but a product would appear on one and only one order. But if we're talking about non-serializable products, like screws, nails, food, clothing, many types of products that are non-serializable. In that case, the same shirt, the same type of shirt, could appear on many different orders, because in that case, a row over here is not representing a single shirt, it's representing a category of shirts. And in that case, we'd keep track of something like quantity on hand. Let's see if I can edit this any further here and add attributes. I think maybe it'd be easier if I don't get into that for this example. Yeah, sorry, I'll ignore that for now. So since this is non-serializable, we're going to use that context. I would have something like quantity of products on hand, but I've also got to change this relationship. No longer can it be many to one, it's now a many to many. Let's see if I can figure out how to change that. Nope, that's not what I want to do. Each one of these are a bit different. Set begin symbol, there we go. Right now it's set to, I've got in the wrong direction. I want to set end symbol, and I want it to be 0 or many. So in this case, an order, actually on this end, should be 1 to many. 1 or more. There we go. So what this means is that an order will only be recorded in this table if there is at least one product on it, but it could have many products. In the products table, we're going to record products even if they've never been sold yet, right? Because we're going to buy things new, buy new products before they're actually sold in the store. So in that case, we need to be able to store products that might appear on no orders at all, but potentially on many. Hence this cardinality. So let's make our products table over in Excel. Let's see, products. Oh, again, shouldn't use plural name. That's not a hard and fast technical rule. You can name entities whatever you want to, but it's just kind of a best practice to leave it in the singular instead of plural form. Product ID, it's our primary key. We'll give it a name, and we'll give it a price. Good enough for our example here. So let's say we offer 4 products. Okay, we have 1-inch nail, 1-inch nails, 2-inch nails, 1-inch screws, and 2-inch screws. Okay, merge and center. Format this to match everything else. Price over here is going to equal 10 cents per nail. Let's copy that down. We'll call this 20 cents per nail and 20 cents per screw. Okay. So now we need to be able to show which products were purchased on which orders. Let's say that order number 1 had 10 1-inch nails and 10 1-inch screws. Okay, so we've got our product IDs. You've learned the rule that to relate these two tables, you take the primary key out of the many side, out of the one side, and you move it over to the many side. However, we have a many-to-many relationship. With that rule, ignore these minimum cardinalities. We're just talking about the maximums. We've got many and many. Remember, the next rule is whenever you have a many-to-many relationship, the only way to map those two together, or relate those tables, without repeating data, particularly text-based data, is to create what we called a linking table in class. And so we're going to put a table in between these two that allows us to copy the primary key from each of these tables into that linking table. And we have instances of products appearing on orders in that case. So if you're not sure why we have to do that, let's look at the data again. And I'm going to insert a few columns here. Insert, insert. Let's scroll over. Okay. Let's clear formatting. Oh, excuse me. No fill. There we go. Okay, so we want to show that product ID number 1 and number 3 both appeared on order 1. So again, if I try to put that here, oops, and we call this product ID, I can put the first product that appeared on that order, but then where do I put product ID 3 that also appeared on that order? I could put it right here, and if I did that, I've got to make sure that every field is unique. I could call this product ID 1, call this one product ID 2, and show that both of these appeared on that order. However, where do I mark the quantity of those products purchased? Also, if order 2 only has one product, and that was it, now I've got a blank space over here, and that's not good. And thirdly, most importantly, we can't automatically add columns while the database is up and running during runtime. We can, but it's complex and taxing on the system, and it's not, databases aren't meant to have columns added automatically. They're meant to have rows added automatically. So that's clearly not going to work. It's clear contents, clear formatting. Let's look over here. We're going to have the same issue on this side. If we try and take order ID and place it next to product number 1, okay, well, the problem now is product number 1 appears on, let's say, all 4 of these orders. That means I've got to plug order ID in the columns, or I'm going to have to repeat rows down here and say 1-inch nails, 10 cents, product ID 1 appeared on order 1, 1-inch nails for 10 cents also appear on order number 2, and now I'm repeating this data in each row. So that's not going to work. That's why every time we have a many-to-many relationship, there's got to be a linking table in between them. So let's create that linking table. First we'll do it in the diagram, and then we'll come back here and do it. Okay, so back in Visio, I'm going to pull this relationship out of there, and actually I'm just going to delete it for now. Let's scroll over here, and I'm going to move the product table down. Let's place another entity right here. Let's call this one, typically whenever you create a linking table, you'll call it something, you'll call it by a combination of the 2 tables you're linking together. Order dash product or something like that, unless there's a semantic or logical name that you want to give to that table. In this case, it's a line item on a receipt. So this table is going to contain a collection of the order ID, product ID pairs, and quantities purchased. So basically a list of all line items on every receipt purchased. So in this case, the primary key, I wonder if it'll let me just click it. No, it won't. Alright, so I'm going to set up, before I fill in those details, set up this relationship here, and now an order will appear many times in this line items table, and every item in this line, and actually there won't be an order unless there is at least one line item on it. So this minimum cardinality, undo, what did I just do? There we go. Is going to be 1 or more. So at a minimum, there's got to be at least one line item on it on an order, but there could be many, hence the crow's feet there. Whereas on this side, we'll only record a line item if it appears on an order, but each line item will, of a particular order, will only appear on one order, hence the 1 and 1 over here. This same logic will apply down here. So I'm going to move that to there, and now instead of a many-to-many relationship, we have 2 one-to-many relationships. But in this case, we'll only record a product, or no, excuse me, we could have products stored in this database even if they don't appear on any receipts yet. So I'm going to change that begin symbol to 0 or more. There, the 0 means that we could have a product in this table without it ever appearing over here. However, we'll only have a line item if it's related to a product in this table. Now the primary key in this case, and let's see if it'll let me adjust this properly. There we go. So we actually have 2 primary keys. I'm going to move that down there. Will it let me? Let's see here. Starting a new tool. Looks like it's not letting me do that. Let me see if I can. No, that's not what I wanted either. Define shape data. That's also not what I want. Sorry for my delay here. Basically, order ID comes over here as a foreign key, product ID also comes over here as a foreign key. I'm just going to mark it over here. And attribute, we're going to keep track of quantity. Now, what I'd like to be able to do is somehow, I wonder if I can copy this whole thing here. Oh, there we go. Perfect. Okay, I'm just going to delete this one altogether and call this product ID. Okay, so now we show that these two together are both foreign keys because we've pulled them in from each table. However, together they make up a composite primary key. So let's understand this now with actual data and see how this works. So over here, I'm going to make a line item table. I'm going to merge and center it. Okay, we're going to format it. Actually, I'm going to make this one a bit longer. I give this one a color. Fill in all the, there we go, the borders. So we have the order ID, product ID, and quantity. Let's resize those. So again, in Excel, select the entire column that you want to resize, and you can select them all at once. And then just hover your mouse over one of these dividers between letters, double click, and it will automatically resize each of the columns to the width of the largest amount of data in any of the rows. Okay, so I told you order ID 1 included product 1 and product 3. So Homer purchased 1-inch nails, one of them. Homer also at the same time purchased 1-inch screws and 10 of those. Alright, let's add a few others in here. Homer later came and purchased 2-inch screws, got 5 of those. In that same order, he also picked up a few more, 2-inch nails. He also picked up a few more 1-inch screws, and 5 of those. Order 3 was also Homer. He forgot that he still needed 4-inch screws, or 2-inch screws, which is product 4. He did 10 of those. Then lastly, that was order 3. Then lastly, Lisa came in and purchased a whole bunch of 1-inch nails. Well, and we'll add 2-inch nails. So notice a couple things about this table. The only thing that's ever repeated are these integers, these foreign keys that came from other tables. The quantity could always be different, although obviously the same number is repeated. It is unique or has meaning different for each one of these. So imagine taking all of your receipts and clipping off everything off the receipt except for the list of products and quantities that were purchased. If you were to do that and then take all of the information in the receipts and plug it into a table, that's what you've got here in this linking table. That's what you have here. So just a list of all of the line item entries on every receipt. You don't need the order date, the payment type. You've clipped all that out. All that information is stored over here in the order table. All right. So there's our example of a linking table with a many-to-many relationship. So for a little more practice, we haven't done an example of a one-to-one relationship yet. Let's add a couple more entities in here. So let's assume, like we did in class, that employees are paid commission for helping customers make purchases. So let's make an employee table, and we'll call the primary key employee ID. Employees have names, and we'll call it commission rate. They're paid entirely on commission, so we've got to keep track of their name and how much they make on each sale. So, which entity do I relate employee to? Let's pull a relationship over here. Employees sell to customers, employees sell on orders, employees sell line items, or employees sell products. Well, this is really a managerial decision for you to make. can you have a receipt where different products are purchased that are by the same customer, yet different employees help them with each item on that receipt? You could make that rule and allow that. It'd be much simpler, though, to say that we only allow a particular receipt to be helped by one employee. In that case, we would relate employee to the orders table, meaning that an employee helped a particular customer with a particular order, and that covers all the line items on that order. So what should we do with this relationship here? Which side does the many go on? Well, let's hook it up and then see if we've done it right, or if we need to make any changes. All right, so the way we've put this in there, this says an employee can help with minimum of 0 orders, meaning we'd store an employee in the table even if they've never placed an order, so that 0 seems appropriate. But they could help with many orders. That's what that crow's feet means. So that makes sense. An employee can help with multiple orders. Reading it the other direction, an order is only going to be recorded if it's placed by a minimum of 1 employee. We may not want to have that rule. We may want to say, all right, some people didn't get any help at all in their purchase. Therefore, there would be no commission assigned to any employee. That's a fair rule, I think. However, at a maximum, each order would be assigned to 1 employee at the most. That's what the second tick means down there. So let's change that to be appropriate. We want to set the end symbol to be 0 or 1. There we go. Okay, that handles that relationship. Let's see, do I want to show that in the data? I think you guys get the one-to-many relationships. And remember, when I say one-to-many, I'm referring to the maximum cardinalities, not the minimums. I'm referring to the tick mark and the crow's feet on the outside here, not the ones on the inside. I think that's good. Let's do one more entity. Let's say that our employees, and we talked about this in class. All right, let's say that they're also assigned, or certain employees, not all. Some employees are assigned a company car because they do corporate sales. They're not in the store helping customers to show up in the store. They're the ones going around and picking up contracts to be suppliers to businesses rather than end consumers. So those people need a company car to travel around with. So let's make a table to keep track of all the cars. And the natural primary key for a car would be the VIN number. Now in this case, a VIN number is a semantic key or an artificial key. It's a semantic key because the VIN number has meaning outside of our database, whereas cust ID, order ID, employee ID, and product ID have no meaning outside of our database. Those are all artificial keys. So as a reminder, we also have primary keys vary along the dimension of simple or composite. Simple key meaning you only need 1 column to make up the primary key, which includes each of these 5 tables here. Whereas a composite key is when you have two different columns that make up the overall primary key. Now, I'm just realizing that I probably didn't explain that composite key very well in the example data. Let me move back here to the data. Notice that I didn't make a line item ID column in here. That's because the combination of order ID and product ID is always different. Never will I see order 1 with product ID 1 listed twice. If they were, let's say a customer, say you're going through a checkout line and a customer buys 2 hammers. The checkout person scans 1 hammer. That creates this entry right here in the database with a quantity of 1. And then later, there's a second hammer, the exact same type that was further back on the checkout line, and the associate scans the second hammer. Rather than create a new entry of 1, 1, 1, we would set up our system to go back here and simply increment that quantity to 2. So no matter what, on a given receipt, you'll never have the same product ID listed twice. As a result, the order ID product ID pair is always unique down through this table. Okay, hence it's a composite key with primary key marked twice. Alright, so sorry for that little sidetrack. Back here to car and employee. Okay, let's pull out our relationship. Let's let's see here. There we go. So we now have a car. A car can be driven or assigned to how many different employees? Well, we should probably make a rule that says one at most. However, are we going to keep track of cars even if they're not assigned to an employee? Yes. So the minimum cardinality over here should be 0 to 1. Okay. Now on this side, an employee can be assigned how many cars? We should probably set a rule that says a maximum of 1. However, do we want to keep track of employees even if they're not assigned to cars? Yes, we do. So the beginning symbol should always also be 0 or 1. So here's an example of a one-to-one relationship. Now, let's go in here and add employees and cars. All right, I'm going to scroll over here and add an employee table with employee ID, name, and commission rate. And I'm just going to make a couple of employees for now. Let's see here. John, Martha. John makes, we'll say 30% commission. Martha makes 35% commission. All right. So before we said the relationship between, let's make this a bit more readable. We'll call it emp ID. Emergent center. Okay, before we said that the relationship between employee and order is one-to-many, meaning that employee ID, the primary key from the one side, is stored as a foreign key in order on the many side. So let's do that. Let's add the, the emp ID of the employee who assisted with that order. Let's fix that. Fix that. Okay. 1, 2, 2. Okay, so now we have that relationship built in, and we can see exactly which employee, 1, helped with each order, 2, and 2. Now let's make our cars database. I'll put it right over here. Car, VIN. Did I record anything else? Oh, I forgot to do the other attributes. We'll call it make, model, year. Over here we'll have make, model, year. VIN, obviously it's a big ugly number. Oops, not that ugly. It's good enough for now. Good enough for now. Call this Ford something, a Toyota something. 2013, 2014. Okay, merge and center. All right. Now, if the Ford is assigned to John and the Toyota is assigned to Martha, could we not simply move all of this right here, right? Because this Ford is going to be, this particular Ford will only be assigned to one person ever, and John will only ever be assigned to one car. So there's no repeated data, there's no blank spaces. In a one-to-one relationship, you could combine both tables into one table and not waste any space and not have any redundancy. The disadvantage of doing that is, let's say that Martha leaves the company, or John leaves the company for a different job, therefore we delete that row. Okay. Now we've deleted that car as well, and that's not the case. We need the ability to remove and add rows to this table and this table without deleting or affecting data in the other table. So when you have a one-to-one relationship, even though you could combine them into one table, that's the best reason for keeping them separate. All right. Hope this has been helpful. I'm going to save these files for you to look at, and I'll post them with this video. If there's anything I didn't answer in this video, any questions that you'd like addressed maybe in another video or that I can answer in class, send me an email and I'll do the best I can to help you. Good luck.